a couple examples. And I did not, where'd my book go? Was not able to write out my answer key for the examples. All right. So today, 2 new ways that we're going to be able to prove that triangles. What? Should be. Yes, I'm recording. I'm already 40 seconds in. Lucky for the virtual students, they get to listen to our pre-lesson conversation. Anyway, 2 new ways that we're going to be able to prove triangles are congruent. Before we get into those, what are the 3 ways that we have right now that we can prove that triangles are congruent? Name one of them. Side, side, side. Side, angle, side. Last one was what? Hypotenuse, leg. Nice. So those are 3 ways that we can prove triangles are congruent. Okay? 2 of them that we are adding today. Angle, side, angle, and angle, angle, side. Okay? 2 of them that we're adding today. So just like yesterday, we're going to look at one of the theorems, check out an example, look at the other theorem, look at another example. First theorem, angle, side angle, congruence theorem. And just like yesterday, if you don't want to write down the little sentence, that's okay. You should be good writing down the picture and the theorem name. So the picture in that statement will tell you everything you need to know. Remember, this is how class was because Marissa and Emma both didn't come till later. Like when we came back to in person, I don't think Emma came back to in person until a week or 2, and Marissa didn't come until a week or 2. Yeah. Then she didn't move to Ludington until a week or 2 after we came back in person. Give you about 30 more seconds to get this written down. So, theorem 5.10. I think it is kind of funny, side note, with all these theorems. If it's 5.10 or 4.10, they write 5.10, not 5.1. I guess we already have 5.1, so that'd be repetitive. But still. Anyway, angle, side angle, congruence theorem. So, just like, by now you guys are getting the hang of these. So if you saw angle, side angle, you could probably guess what that means. But the formal definition is if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of a second triangle, then the 2 triangles are congruent. So again, that idea of an included side comes up, where we have our included angle, where we have a side, and then in order to have angle, angle, side, the angle needs to be connected to that included side. Keep saying included side. Those angles need to be connected to the side, so they would be considered included angles. So if angle A is congruent to angle D, and line segment AC congruent to DF, and C is congruent to F, then the 2 triangles are congruent. Write proof. Given that AD is parallel to BC, and that BD is congruent to BC. So if we start out with our statements here, we just are repeating the given. AD parallel to BC, and BD congruent to BC. The reason is because this is the given. Now, what if we're thinking about angle, side, angle? Which part of proof of using angle, side, angle does this help us with? Does that prove any part of it for us already? We're trying to use angle, side, angle to show that these two triangles are congruent. Just from looking at the given, does that give us an angle, a side, or an angle? What? Maybe. I think it does for sure. It tells us BD is congruent to BC. So that would give us a side. So now we just need to prove and go through what two angles, if we know that we're working with this side right here, we need to prove the congruence of these angles. Okay? Which one of these could we prove pretty quickly? And why? Which one of these could we prove pretty quickly? We're looking at angle D congruent to angle C, or could we prove angle, both sides of angle B are congruent pretty quickly? B and C. We can prove pretty quickly that these two sides are congruent, right? We could say that angle D, BA, this angle right here, DBA, is congruent to angle CDE. And this would be because they're vertical angles. So that would give us our second angle here. Now the only other angle that could work, we're using angle, side, angle. It has to be the inclusive angle. So we have to be using D and C. We have to be saying that these two things are congruent. Does anyone have any ideas for how we could prove that those are congruent? I'll give you a hint. It has something to do with these two lines being parallel. They're what? Remember all the way back to when we did the transversals? Remember, transversal was two parallel lines cut. Whenever they tell us that lines are parallel, that's a big hint that we're going to be using like alternate interior, alternate exterior, or something like that. So if these were two parallel lines right here, cut by a transversal, those two lines in the yellow, I know it's kind of hard to see, it's so bright outside, we got glare on here. But those two lines in the yellow, what relationship would they have?
Didn't I say it was representing alternate interior?
They'd be alternate, but they would be not into. Wait, what did you say?
Alternate interior.
Oh, sorry. Yes, that's exactly right. There'd be alternate interior, right? Interior because they're inside the parallel lines, and alternate because they're on separate sides of this middle line, that middle line that cuts it open. Well, not open, but cuts it. So you have angle D is congruent to angle C because they're alternate interior angles. So now, if, again, these different things that we've went through, side, 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 hypotenuse, leg theorem, side, angle, side, and now angle, side, angle. These are just tools we use to prove that the triangles are congruent. We just look at the information that they give us in this question up here, and we can say, all right, out of our tools, in our toolbox, we can use angle, side, angle to prove that these two triangles are congruent. So our last step would be just to state that that's what we use. We can say triangle ABD congruent to triangle EBC because of angle, side, angle. What questions do you guys have on that first one? Taylor?
Hmm.
You with me?
Yeah, I'm listening.
You listening?
Mm-hmm.
Hello?
Hello.
What can I do for it?
Here, you can like this is fine. I don't know why.
You just delete space.
Oh.
So I think, well, that's one thing. Delete the space, and then you want to switch your question type to fill in multiple lines,
Okay.
and then you should be good. There you go. You're close.
So close.
That's impressive.
Thank you so much.
No problem.
Oh my God, you have something great.
Yep.
Crazy.
Yep, you're good. Are we getting used to these proofs a little bit and more comfortable with them? Right now, it's nice because they tell us, hey, you're going to be using angle, side, angle. So we just need to put the pieces together to prove our angle, side, and our angle. Let's look at our next theorem, one more example, and then something different. So, theorem 511, angle, angle, side.
This is the same thing as this reading.
It is. That was going to be one of my questions. What's the difference between, you can be thinking about this when you write down, what's the difference between angle, angle, side, and angle, side, angle? Again, you probably don't need to be writing down that middle sentence, but write down the name, and write down the statement. There, at the bottom. Also, if you get a second and you want to write down, like in a quick sentence, the difference between angle, side, angle, and angle, angle, side, then I would give you a bonus point on the test. Did you catch that? Well, I'll tell you, but at first, I'll give you an opportunity. If you can write down in this, like a quick sentence, the difference between angle, side, angle, and angle, angle, side. Because it's the same letters, right? We're still using two angles. We're still using one side. But why? How are they two different theorems? What's the difference?
How am I supposed to know?
Well, you're not. That's why I give you a bonus point. It's starting to get cold. Well, it's not cold yet. It's like,
It's
because it's been in here for like 4 hours.
4 hours? I've been here since 5 and you haven't even closed the slides. We told you.
Oh, I thought it was 10 something. I've been here since. Today I got here late. Usually I get here by 6:15. Today I got here at 7. So I guess it's been in there for 3 hours. I know. talk to her earlier today? Something was going on.
She's looking at all of these classes
Just laid on the floor.
and sleeps or watches Netflix. That's what she does in this French class. She skips third hour.
Third hours aren't important.
Fifth hour, she literally does nothing but goof off the whole time.
Alright, let's take a look at this one. Alright, does anyone have an idea for what the difference is? Why do we have two different theorems? Even though we use all the same letters. It's okay if we don't. It's a little bit tricky, but when I say it, you think, so, theorem 511, angle, angle, side. If two angles in a non-included side of one triangle are congruent, the two angles in the corresponding non-included side of the second triangle, then the two triangles are congruent. So one key thing, well, there's a couple key things. First key thing that we need to point out is that notice that angles that are congruent need to be the corresponding angles. Okay? So, in other words, in this diagram, if let's say angle F wasn't a congruent angle, say it was like angle E, that would not be the corresponding angle to angle C. You're following with me? Angle B would be the corresponding angle to angle E. So we could not use angle, angle, side in this situation. So make sure it's the corresponding non-included side of the second triangle. The difference between angle, side, angle and angle, angle, side is that with angle, side, angle, we use a side and then the two included angles. Okay, that's angle, side, angle. With angle, angle, side, we do not use the two included angles. Right? We just use one of the included angles with our congruent side. So same idea. But just one of them we use the included side, the other one we do not. So, like you could have guessed, right? Proof. First, let's start with the given. Again, remember, keep in mind, in this case we have to use angle, side, angle. Or, sorry. Angle, angle, side. Now, when we see a right angle, what's the first thing that we talked about yesterday that we should think of when we see a right angle? What congruence theorem did we want to use when we see a right angle? The what? That we talked about yesterday. We talked about two of them yesterday. When we see a right angle at triangles, what congruence theorem did we talk about that we probably want to use? Yeah, the HL, hypotenuse leg, because that applies only for right angles. Now looking at that picture, why could we have the picture and the given, why could we not use the hypotenuse leg theorem? What's missing? Because we have the 90-degree angles, right? We have two right triangles, and the hypotenuse is congruent because they have the same hypotenuse. So what's missing? No idea? Well, remember, hypotenuse leg, we have to, at first has to be a 90-degree, a right triangle. We need to have a hypotenuse that's congruent, which we have, but we also need to have legs that are congruent. And with the given information, they tell us that FH and GK are parallel, but they do not tell us that they're congruent. So we have no way of proving that any of the legs are congruent. So we cannot use the hypotenuse leg theorem. Correct? What they do tell us is that HF and GK are parallel. Parallel. So that helps us a lot down the road, just like last time. So if we're writing our proof, we ever given HF parallel to GK, and then also F K that's how we will try it. Now, if we're trying to prove angle side, what did the given already tell us? What did the given already tell us? If we're trying to prove angle side, which part of that did the given already tell us? Well, they tell us we have parallel sides, which we'll use, but that didn't tell us that the sides were congruent. If F and K are right angles, what does that mean? F and K are what? They're congruent. Yeah, I'm not trying to trick you. If F and K are both right angles, then they're both 90 degrees, which means they're both congruent. So our first statement can be angle F is congruent to angle K. So here would be an angle. And our reason for this, even though they talk about it in the given, but our reason for this technically would be either like the definition of right angles, or we also would call it the right angles congruence theorem. But if you put definition of right angles, then I would be good with that. You guys following with me? We're doing okay? Are we sick of proofs yet?
Yeah.
You guys have done a really good job with them. So stick with it. I think these are the last types of proofs that we would be looking at. Yeah.
What do you mean triangle?
We have coordinate.
Yes or no?
We have coordinate proofs left still. But those
No.
are a little bit different.
Line.
No, I didn't lie. We skipped the whole chapter on proofs. So I think we can handle a little bit of proofs here. So we have one of our angles, right? Now, what side? Yeah, we'll go here, this direction. What side of the triangle can we prove, or what sides of each triangle can we easily prove are congruent? What side do they both have that we can easily know is congruent? Yeah. Which would be what? Yeah. GH is congruent to HG. Reflexive. Or reflexive. I just realized today I've been spelling reflexive with an S, and there is no S in reflexive. So that's cool. That's how it's spelled, right? Reflexive. I kept spelling it like this. That's okay. Maybe I won't. I don't think I'm clear.
You know what? I was watching YouTube vlog yesterday, and on my recommended page, it was like, yeah.
Yeah.
Freaking thing. It's like a lesson. Show your video. I'm like, I don't want to watch that. I was like, get out of my
That's what I'm talking
face.
about.
Mr. Lane, he was on your recommended page?
Yeah, because I'm subscribed to his YouTube channel.
Yeah.
Oh, you
And I
have a
post
YouTube
every day. New content daily.
New
Oh.
content.
Is it about math?
Yeah.
It's our lessons. Like what I'm recording right now will go on our YouTube page.
Oh.
Yep.
I was like, really? It was like 10 at night. I was like, I don't want to watch this.
All right, so we have
I was
angle.
like, are you kidding me?
We
I
have-
have to deal with him enough.
You don't get to see me enough. I think that's what you meant.
No.
We have an angle and we have a side, right? Now we've used this side and we have used this angle here. So that means that whatever side we use, it has to be one of the inclusive sides here. So remember, when they tell us that we have parallel lines, that automatically means that we need to be thinking about our relationships, like our corresponding, alternate interior, and all that kind of stuff. So if we had a transversal, what angles could we say are congruent? G and H? G and H. Yeah, like those sides of each of the triangle. I would agree. Double check. Yeah, perfect. Yeah. So we have alternate interior angles. Yep, because of those parallel lines. Right here. So we could end by saying angle FHG is congruent to angle, let's see, KQH, and this is because of the alternate interior angles here. And that would be our other angle. Now, we still, at our end, at the end, we still need to state that these are congruent. So when you say triangle HFG is congruent to triangle EKH, then this is still, even though we went in the order of angle, then a side, then an angle, the order when we proved it, we used angle, side. And remember, we used angle, side because we had a side with one of the inclusive angles, but then the other angle that we used was not an inclusive angle. So that would make it angle, side.
I'm over it.
Super cool, right?
No. I'm over it. Angle side, right.
Here are all the theorems we've looked at. 5 different ways that we can prove that triangles are congruent.
I think it makes me cry.
No. And at some point, not today, today we'll just be looking at these two, but at some point, like, a very good question would be that I have you look at a proof, and then you have to decide which one of these they use.
The tick mark is on us for angles. No.
Not always. You have to be looking, not always. I mean, there might be a couple, but there will be times where I just give you the information and you'll have to, based on the information you're given, you'll have to decide which proof, which approach you'll have to use. Okay?
For those two, it's just whatever the tick mark on the first one is where the angles are on the same line as the other one.
For these two
Yeah.
that we
The
just
tick-
looked at,
Yeah, that one has the tick mark on the same line that the angle's on. and
Exactly.
The other one doesn't.
yep, we would say that both angles here, and angle, side angle, both the angles that we use are the inclusive angles. So they're connected to our side. For angle, side, we use one inclusive angle and then one non-inclusive angle.
It's where the line.
Right. Where the line is what angles we use. Okay. Go on to class kick.
Oh, I cannot with that person diagram.
Super cool.
It's so bad. Who made that?
Grab your iPad, grab your iPad, grab your iPad.
Yeah. I don't even think
Get
we
the
have
class
that.
kick app.
Oh, the app?
Yeah.
It'll take like a million years for that to be
That's
done.
gonna take a hot minute.
No, it won't take that long.
Yes, it will.
School don't like having good Wi-Fi.
It's really dumb.
Oh, I'm still recording.
Okay, and I'll tell the principal myself. You ain't got good Wi-Fi, my guy.
I don't think he has a whole lot of control over that.
Well, tell the school board has